Okay, so I hope all of you can see the screen. Hello, can you see? Okay, okay, okay. So I hope all of you can see the screen. Okay, so now uh, in the last class, I think this is the last problem which we have discussed in the last class. Is it? I think this was the last problem which we have discussed in the last class. Find the moment of resistance of a cantilever beam. Okay, okay. So, so let us move. I hope all of you have understood the last class problems. Yes or no? I hope all of you have understood whatever we have discussed in the last class. Okay, okay. Okay, so now let us move to the next problem. Okay, so whatever problems discussed in the last class, it is seen that in most of the problems you are asked to find out the moment of resistance. Okay, and also in I think in two problems we need to find out the UDL also. Okay, so this is the problem which we, where we have calculated moment of resistance, and then we have calculated the uniformly distributed load. Okay, so in the next type of problems we will determine the stresses. Okay, that means moment of resistance value will be given to you, and based on that moment of resistance value, what will be the stress developed in concrete and what will be the stress developed in steel, we have to find out that. Okay, so you can see in the screen, example, this is the type 2 problems, determination of stresses. That means in the next few problems we have to find out the stresses which will be developed in concrete as well as in steel. Okay, so now all of you please read the question and try to understand what we are going, what we have to find out. Okay, this question, example 2.6, I hope all of you can see it. Okay, okay, and you read the question and try to understand what we have to find out. Okay, RCC beam 400 into 600 effective, that means our dimension of the beam is given, is reinforced with 4 bars of 25 millimeter diameter. That means area of steel also we can find out from this information, 4 bars of 25 millimeter diameter. Okay, next it is given that the beam is subjected to a bending moment of 150 kilonewton meter. That means it is given that a external moment of 150 kilonewton meter is acting on the beam. Then you are asked to find out the stresses that will be developed in steel as well as in concrete. Okay, and also it is given that your modular ratio value is 13.33. Okay, so now we have to find out sigma means stress in concrete as well as stress in steel. Okay, but we don't know in the previous problems. You can see okay, let us move to the previous problem. You can see in all the previous problems your grade of concrete was given, say M20 concrete, and grade of steel was also given. So from those values we can see in the previous problems, in all the previous problems, grade of concrete and grade of steel was given. So based on those values we can directly find out the values of sigma ST and sigma CBC from IS 456. That means from table number 21 and 22, if this grade of steel and grade of concrete is given to you, you can directly find out the stress in concrete and the stress in steel. Okay, but in this question, in the current question, it is nothing is mentioned about what is the type of steel and what is the grade of concrete. Nothing is mentioned. Okay, so we can't use the table 21 and 22 because we don't know the grade of concrete as well as we don't know the grade of steel. Okay, so first you write down the given data, this 400, and one thing you remember in the last class also, I think I told you, whenever the dimension of a beam is given, the smaller value will indicate always indicate the width of the beam. Okay, width of the beam will be always smaller than the depth of the beam. Okay, so you can see this in your home also. If you are staying in a RCC house, you can see the size of a beam. Okay, if you see the size of a beam, you can see always the depth is more than the width. Okay, so this smaller value will be the width of the beam, that is our B, and the higher value will be your depth. Okay, so now in this question it is mentioned, this word is mentioned, effective. That means it is the value of small d. But in some question, it might be given directly that an RCC beam 400 into 600 mm. And if this word is not mentioned, then you have to understand. If this word, effective word, is not mentioned, then you have to understand the bigger value will indicate the overall depth. Okay? If this effective word is not mentioned in any question, then you have to understand that the bigger value is indicating the total overall depth. Okay, overall depth of the beam is given. But in this question, it is directly given effective. That means it is the value of small d. Okay. So now we are using 4 bars of 25 mm diameter. So we can find out the value of AST also. This is our AST, 4 into pi by 4 d square formula. Okay. So next, our moment is given. One external moment is acting on the beam, which is 150 kilonewton meter. Okay. So we need to find out the stress in steel and concrete. Okay. So first we will determine the neutral axis. Okay. So actual neutral axis formula is same, which we have used in the last class. This is the formula for finding out actual neutral axis. B n square divided by 2 m into AST d minus n. So now B is given, m is given, AST is given, d is given. Only unknown is your n. N means depth of neutral axis. So from this formula, you can find out the value of n. So our n will be coming out as 222.32. Okay, so as you have pen and paper with you, I expect all of you to write down. I will share the PDF with you after the class, but during the class, I expect everyone, please write down, at least write down the solution. Okay, write down the solution and try to understand how you are getting the values. Okay, otherwise after the class, if I share the PDF, you can study from that, and if you solve the problem during the class only, it will be better to understand. Okay, so that if you have doubt during the class, you can directly ask me why this value is coming, how this value is coming. Directly you can ask me. Okay, but after the class, when you are going through the PDF, if you have any doubt, you can always ask me directly, or okay, or you can ask me in the next class also. Okay? Is splitting in the middle term done to get the value of n? I didn't get your question. What you are trying to ask me? Okay, to Achumi, I didn't get your question.
Sure.
Yes.
From the n square is n square plus 13.130.86. How do we get the value of n?
Is splitting the middle term done to get the value of n? Splitting means what? Splitting?
Like we used to do that in experimental time to get the value of n. How did we get the value of n?
Yeah, you solve the equation. This is a quadratic equation. You will get two values of n because you can see n square is there. You will get two values of n. One will be positive, another one will be negative. We have to take the positive value. You cross multiply this one, 2 into this part, then you multiply this one, then you shift this negative part this side. You have to take common and you have to solve this equation. Okay, and I hope all of you can solve this. This is a simple, very simple equation, this one. And if you have some
But
calculator also, your calculator will give you the answer directly. And it is a very simple equation. This is a quadratic equation. You have to cross multiply this one, 2 into this part, then you break it again.
no, sorry. Next line. Next
Next
line.
line,
Next
this
line.
one. This line.
From this line to the last. Yeah, from this line to the last line.
Okay, last line, this one. Okay. This is the quadratic equation. Use your calculator to find out this answer. Otherwise, actual formula is this one. I'll show you here. Yeah, this formula. This is a quadratic equation. Ax square plus bx plus c equal to 0. In your calculator, when you type equation, then you will get the form ax square plus bx plus c. Okay. So now in place of x, X means your unknown. Okay, so in this equation our unknown is n. Okay, okay, so I hope you have got this answer. Is it okay though? Okay, you got it. Okay, okay, so now we have got n equal to means depth of neutral axis is 222.32. Okay, so next what we have to do in this question, see, we can't find out directly what is the type of section. Okay, because we can't find out the critical neutral axis. Is it? Because our sigma st value is not known, we can't find out sigma st directly. Our sigma cbc value is also unknown, so we can't find out sigma c, that means this value we can't find out now in this question. Okay, this value we can't find out directly now in this question. We can't use this equation because to use this equation these values must be known. This sigma cbc must be known and sigma st must be known. Okay, but in this question these values are not given, so we can't find out nc, and as a result of that we can't say directly that our section is balanced section or under reinforced or over reinforced. Okay, so what concept we will use? We will use that. Okay, so can anyone tell me what will be the type of section in this question? Because we can't find out nc, and by comparing those two values we can't say what is the type of section. So can you tell me what will be the type of section in this question? What will be the type of section in this question? Because we can't find out the value of a critical neutral axis. Can anyone tell me what will be the type of section in this question?
Over reinforced.
Over reinforced. Okay, next. Any other answer? Any other answer?
Sir, balance.
Balanced. Okay, any other
Balance
answer?
section.
Any other answer? Any other answer? Okay, to Achumi, what will be the type of section? I am guessing balance section.
Sir, I told.
Okay, okay, okay. I am guessing balance section. Okay, and do you have any other answer? Anyone have any other answer? Shirodha, what will be the type of section? Over reinforced. Marilyn, Oinam.
I don't know, sir.
Okay, okay. Okay, Jashila, what will be the type of section?
Sir, I'm guessing under reinforced.
Yes, I told you in the first class while I was explaining what is balance section, what is under reinforced, what is over reinforced section. I told you that always we will go for under reinforced section because balance section is not possible actually. Okay, so and we will never go for over reinforced section. So in this question, since nothing is mentioned, we have to consider that our section is under reinforced. We can't consider balanced or we can't consider over reinforced because over reinforced we will never go for over reinforced section. Okay, so we will use the equation of under reinforced section to find out the value of moment of resistance. Okay, you can see in this question. See, this is the equation. This is the equation for an under reinforced section. Okay, so whenever if it is in any question, if nothing is mentioned, always you have to assume or you have to know that our section is under reinforced. Okay, then only it will be stable. Okay, so now we will use this equation to find out the moment of resistance. Okay, so moment of resistance equal to, we know the formula, sigma st into ast d minus n by 3. Okay, but in this question sigma st is also not known. Till now we don't know the value of sigma st. What will be the value of stress in steel? Till now we don't know. Okay. So therefore, in this equation, you can see sigma st value is there because we till now we don't know what is the value of sigma st. Okay. Okay. So next, this is the moment of resistance value. Okay. This is the moment of resistance value. Next, we need to find out this value sigma st. Okay. Sigma st means stress in steel. Okay. So now in our question it is given that 150 kilonewton meter bending moment is acting on the beam. Okay, so you can see the equation here. You can see the equation. Moment of in the question, whatever moment is given, actually it is nothing but our moment of resistance. Okay. Okay, so we will equate this moment of resistance with the given moment. M equal to mr. M value is given 150 kilonewton meter. Okay. Okay, you can see the equation. Hello, can you see the equation? This moment of
Sir.
resistance will be equal to the moment which is given in the question. Okay, so equate the two equations. This value equal to 150. It is given in kilonewton meter, so we will convert it in Newton millimeter, so it will be multiplied by 10 to the power 6. So if we equate these two equations, then we will get the value of sigma st. Okay, it will be coming as 145.36 Newton per millimeter square. Okay, so I hope all of you have understood till this portion. Is it? All of you, did you understand till this part?
Yes, sir.
Okay, okay. Okay, so next, another thing we have to find out, sigma C means stress in concrete. We have to find out stress in concrete also. Okay, so we have got the value of sigma st. So now we have to find out sigma C. Okay, so for that, can anyone tell me which equation we have to use? Which equation we have to use to find out the value of stress in concrete? Anyone? You can go through the class note or you can go through the PDF which I have shared with you in the last class. You can see all the formulas given. Can you tell me?
Sigma C by N.
Yeah, which formula we have to use?
Sigma C divided by N equal to sigma ST by M divided by N minus N, D minus N.
Yes, good.
Critical neutral axis.
Yeah, good. See this formula.
M
Yeah, we have to use this formula. Okay, I think all of you have got this. In the last class also, we have solved this question. We have used this equation. Sigma C divided by N equal to sigma st by M D minus N. Did you get this formula in the last class? Yes or no? Have you got this formula? Okay, to? Yes, no? Okay. So in this equation, see only value is sigma C. Okay, all the things are known. We know the value of N, which is 222.32. We know the value of sigma st, which is 145.36. M value is given. D is known. Okay, so if you put all the values, we can find out the value of sigma C. That is our stress in concrete. Okay. Did you get the answer? Did you understand this equation?
Yes, sir.
Okay, okay. Okay, and I hope all of you have understood this problem, is it? Very simple question. It is nothing. I don't think it is hard. Is it? Okay, can you move to the next problem? Can we move to the next problem?
Yes, sir.
Okay. Okay, so next problem, all of you at least try to do the first part. Okay, try to find out
Do the first part. Okay, try to find out
and moment of resistance for the second problem.
and moment of resistance for the second problem.
See this problem, read the question and try to find out the value of neutral axis and moment of resistance. Same question, RCC beam, dimension is given, AST you can find out. Now this value is given. This value we will use later on. Okay, actual stresses developed in steel and concrete. So now you find out the value of depth of neutral axis. Find out the value of n. Find out the value of n. Did you get the answer? N equal to how much? N equal to how much you have got? Yes, good. 208.97. Good. Poinam, correct answer. Lines. Yes, 208.97. Okay. Yes, good. 208.97. Next, we have to find out moment of resistance. Similar to the last problem, find out the moment of resistance. Find out the moment of resistance and try to find out the value of sigma st. Did you get the answer, anyone? Okay, 666450 sigma st. Okay, wait, I will check the answer. Okay, good. No, what will be the value of max? Okay, so moment of resistance is, okay, moment of resistance 666450.64 sigma st. Okay, so next you find out the value of sigma st. Next you find out the value of sigma st. This is the equation for moment of resistance. Next you find out moment of resistance, similar to the last problem. Okay, so this is little bit different from the last problem, because in the last problem the moment is directly given to you. Bending moment value was directly given to you. But in this question you can see it is given that the beam is carrying a superimposed load of 50 kilonewton per meter. That means UDL value is given. Okay. And the effective span is also given. So first of all we have to find out the moment. First of all we have to find out the moment. Then we have to equate that moment with the moment of resistance. Okay. So can you tell me what is the formula to find out maximum bending moment? Anyone? In the last class also I told you what is the formula.
WL square by 8.
Yes, good. WL square by 8. WL square by 8. See, for simply supported beam, the maximum bending moment is WL square by 8. Okay. So find out this value. W is your 50. L is given. Effective span is given 4. So this one, if you solve this equation, you will get 100 kilonewton meter. That means 100 into 10 to the power 6. Okay. So next you equate this value and this value and find out the value of sigma st. So sigma st will be coming out as sigma st will be coming out as this one, 150.05 Newton per millimeter square. Did you get this value? All of you? Sigma st will be 150.05 Newton per millimeter square. Okay. So up to this part, it is exactly similar with the last problem. Only here, this formula we have to use. In the last problem, this value was directly given. This is the difference till this part. Okay. Have you got the answer, this one? 150.05, everyone? Okay, so Achumi, did you get that?
Yes, sir. Yes, sir.
Okay. Okay, so next you see the question. What we have to find out. Okay, so now for this you find out the value of sigma c. Similar to the last problem, find out sigma c. By using this equation, find out sigma c. Sigma c by n equal to sigma st by m. Use this equation and find out the value of sigma c. Maximum stress in concrete. And after getting the answer, as soon as you get the answer, write down in the chat box. Write down, after getting the answer of sigma c, you write down the value in the chat box. So did you get the answer, anyone? Anyone got the answer? Sigma c. Use your calculator. Why you are taking so much time? Use your calculator. You will get the answer within 2 minutes. Okay, so you will get sigma c equal to 6.01. I hope all of you have got the answer. 6.01. Achumi, did you get the answer? Sigma c equal to 6.01?
Yes, sir.
Okay.
I wrote in the chat box.
Okay. So in the previous problem, this up to this portion we have solved, is it? In the previous problem, we have solved up to this part. We have calculated sigma st and sigma c. Okay, so one thing you have to understand, this sigma st, this means maximum stress developed in concrete steel. Okay, sigma st means maximum stress or permissible stress developed in steel. And since in this equation we have used this maximum stress in steel, so whatever value we will get, this will be the maximum stress developed in concrete. This sigma c indicates the maximum stress developed in concrete. Okay, so now can you tell me in which portion of the concrete you will get the maximum compressive stress? Because in concrete compressive stresses are developed. In steel will carry the tensile stresses. Okay, so now if I ask you in which portion of the concrete you will get the maximum stress, maximum compressive stress, in which portion of the concrete you will get the maximum compressive stress?
Sir, above the neutral axis.
Above the neutral axis where? Above the neutral axis where? I am
The
asking
top.
maximum. At where you will get the maximum value? Anyone got the answer? In which portion of the concrete you will get the maximum stress? Compression zone. That means in compression zone, I know that compression zone, but in which point of the or in which section of the compression zone? At every point your value cannot be maximum. I am asking you the maximum value because this sigma c indicates the
Sir, in
maximum
the
stress.
top layer, sir.
Yeah. Where? At the
Top layer.
at the topmost.
Top layer, sir.
Yeah, at the topmost layer. At the topmost layer, you will get the maximum stress, maximum compressive stress. Okay, so this means this 6 Newton per millimeter square, it is the maximum compressive stress developed in concrete at the topmost layer. Okay, so now in this question, another thing we have to find out. Okay, let us go to the question. You see here. Also find the compressive stress in concrete at 50 millimeter from the top of the beam and draw the bending stress diagram. Okay, that means we have to find out the stress in concrete at 50 millimeter from the top. Okay, so can you tell me at 50 millimeter from the top the stress value will be more than this sigma c or it will be less than this sigma c?
Less, sir.
Yes, good.
Less, sir. Less.
Less. Okay, yes. At the topmost layer, we are getting the maximum value, but we need to find out 50 millimeter below the topmost layer. Okay, so that stress will be less than 6.01. Okay, and we need to find out that value. Okay, so now, do you have any idea how to find out that value? Anyone have any idea how to find out that value? Do we have any formula for doing that, for finding out that value? Do we have any formula?
Sir,
Yes.
I think since we're going to find out the stress, we'll use the same formula.
Same formula. No, we can't use the same formula.
Sigma
If you are using the same formula,
sigma c by n.
sigma c, no, we can't use the same formula. Anyone have any idea how to find out this stress at 50 millimeter below the topmost layer? Anyone have any idea? If anything is coming to your mind, just write down in the chat box, or you can tell me. If anything is coming to your mind, just tell me. Your answer may be correct, may be wrong. Just tell me. Whatever you are thinking, just tell me how to find out. Is there any formula or is there any way to find out the stress at 50 millimeter below the maximum level or topmost fiber? Wilson the Burma, can you tell me how to find out?
No, sir.
No. Shiroda?
No, sir.
No. Benison? Benison?
Sir.
Okay, so I will tell you one thing. Okay, so Benison, can you tell me how to find out? Oinam? Okay, okay. Okay, so I will tell.
No, sir.
No, okay, okay. Okay, so I think in the first or second class, I have given you some diagrams. Diagrams means how to find out stress, means, okay, I will show you that PDF. Do you have the PDF, have this PDF with you? I think all of you have this PDF with you. Is it?
Yes, sir.
Okay, so in this PDF, in this, see the diagram. This is our beam, okay? This is our beam. This is our beam in which our B is given. D is known, capital D is known, this N value is known. This sigma C value is known. This sigma ST by M is known. Okay, so now we need to find out the stress at 50 millimeter from this level. From this level, we need to find out stress somewhere here at 50 millimeter from the top layer. We need to find out this value. Can you find out from this diagram? Can we find out from this diagram? Anyone have any idea? I have given you 90% answer. Just tell me how to find out from this diagram. We have this value. We have this height. We have this, the topmost height also we are given 50 millimeter.
Yes, sir.
Okay, so how to find out?
So I think we have to subtract 50.
We have to use the property of similar triangle. Okay, now you see this screen. See the screen now. This is our section. Okay, this is our section. Okay, this is our section. At the topmost layer, we have stress sigma C, which we are already calculated. At 50 millimeter from the top, this height is 50 millimeter. That means somewhere here. Somewhere here, we need to find out the value of sigma. Okay, so now you can see two triangles are there. This A, B, C. This is one triangle, this big triangle A, B, C. And there is another triangle A dash, B dash, C. Can you see these two triangles, all of you?
Yes, sir.
Okay, so these two triangles are similar because this, if you consider this angle from the big triangle, it will be 90 degree. And if for in this small triangle also, this is 90 degree. Okay, and this angle is the common angle in both the triangles. So this angle and this angle will become equal. So now we can use the property of similar triangle. Okay, so how to use the property? If you take this side of this big triangle ABC, AB, then you have to take this side A dash B dash from the small triangle. You can see here AB divided by A dash B dash equal to, if you take this height AC, this length from the big triangle, then you have to take A dash C from the small triangle. You can see here. Okay, so now AB is nothing but the stress in this length represents nothing but the stress in the topmost layer, that is our sigma c, and the value is 6.01. And at A dash B dash, this length represents the stress at this level, and we need to find out this value. And I am writing here sigma c dash, and this value is unknown. AC value is known. AC is nothing but our neutral axis depth, which is our 208.97, and this A dash C is 208.97 minus 50. Okay, so if you solve this equation, you will get the value of sigma c dash. Okay, so do you understand this equation now? All of you, can you find out the value of sigma c dash now? Okay, to Achumi,
Yes, sir.
Wilson,
Yes, sir.
can you find out the value now?
Yes, sir. Yes, sir.
Okay, and do you understand how we have used this formula?
Yes, sir.
Okay, so we have to use the property of similar triangle. Okay, and you find out this value. Okay, so I will show you the value. Your value will be this one, 4.57. This is our final diagram. Okay. Okay, so one thing, our class is going to be over now. So all of you have got the attendance. No need to write down in the chat box, and no need to text me also. Okay, all of you have got the attendance. Okay, and this is the final diagram. After getting the value of sigma c dash, we need to draw this diagram. Okay, this is the value of sigma c, maximum stress at 50 millimeter. This is the value of sigma c dash, 4.57. This is the value of sigma, this length is sigma st by m. Find out the value. This is the final stress diagram. Okay, okay, so after the class I will share this PDF with you. Okay, no need to worry for that. And I hope all of you have understood whatever we have discussed today. Is it? Okay, to Achumi, I hope all of you have understood today's problems. Yes?
Yes, sir.
Okay, okay, thank you.